This meeting is being recorded.
In this next video from chapter 17, we're going to look at a new concept here, something called the selective precipitation of ions. So if we have a solution of mixed ions, this selective process through selective precipitation involves utilization of the KSP value. So whoever has, whatever species has a lower amount of an ion that's needed to start precipitation, we can figure out when we have a mixed solution which of our salts would precipitate first. And again, we're going to relate this to our KSP value. So let's take a look at this question here, sample exercise 18. And if we have a solution that is 1.0 times 10 to the negative 2 molar in silver, and 2.0 to the negative 2 molar in lead 2. When chloride is added, both salts, the silver chloride and the lead chloride, will precipitate. But first we're going to find what concentration of chloride will be necessary to begin precipitation of each salt. And then we're going to answer this question here, which of the two will precipitate first? So that's going to be whichever needs the lowest concentration of chloride, that will be the one that begins first. So let's see what we have in part 1 here. So I've written out our two salt ionization equations. So we have silver chloride gives us silver and chloride ions. Our KSP expressions over here for that. So we have concentration of silver times concentration of chloride will equal this 1.8 to the negative 10. So all we have to do here is, I've written it down here, is plug in our value given for our silver ions. We're going to divide that over here, and then we're going to get our chloride ion concentration. So 1.8 to the negative 8th, that's what's needed to begin precipitation of our silver chloride. Next, we'll take a look at the KSP expression down here for our lead chloride. So we plug in the starting concentration of our lead ions. We're going to start adding some chloride. Notice that in the KSP expression, I have this squared. So what we're going to do is we'll divide by the lead concentration, and then we'll take the square root of both sides, and this will give us the needed chloride ions to start our lead chloride precipitation. So this is 2.9 times 10 to the negative 2 molar. So recall that a smaller negative exponent means that we need, a larger negative exponent means that we need a smaller amount. So since this is the smaller value, we would say that this, our silver chloride, would precipitate out first.